Welcome to this new video tutorial for Cancha. Today we're going to be talking about the analysis part of the software, where you can use graphs and plots and summary tables to analyze data. We're using Cancha 1.3, and without further ado, let's get into it. We've got a made-up data set. As I've said in previous tutorials, there's a lack of a public data set that we can use for geometallurgical education, and so we don't have good examples for Cancha that we can publish. We've got hundreds of data sets from different mines that we've worked on over the last 20 years to develop this software, but it's all proprietary to our clients, so we can't share it with you. So if anybody out there has a data set that they can share with us, please feel free to get in contact with me, and we'd very much appreciate having a public data set that we could use for education. Right, so having said that, let's get into the analysis. So here we are, in Cancha, we've got the toolbar at the top, which takes us to each individual area. And you can see here we've got a data set that's all been fabricated. We've got the 3D and the logs that you've seen in other tutorials. And now we're going to talk about the analysis. In the analysis, we've got different kinds of graphs and tables that we can draw. The first one on the left here is a matrix plot. This isn't the plot of the movie Matrix, rather it is a kind of plot that gives us a matrices of different co-correlations between different features. So how does this work? Well, first of all, like in a lot of Cancha, we're going to have to drag features from the feature window here on the left into these dialog boxes, the list boxes on the right. And that's going to populate things. So what we're going to use in the first place is we've got some correlation here that's probably going to come out of some comminution data. Some different comminution data here that we've made up. This one here is a bond work index. Now, obviously you have to give it other things to correlate to. We could, just drag in, for example, abrasion index and SG and the SMCA by V, for example, and just hit apply, and we'll get a correlation plot for these. Now you see we've got a little orange corner here. This is what we use to scale all of the different graphs with. You'll see this in most of the modules. Just scale things around like that. So we can already see that we've generated this quite quickly. We've got basically a unit vector here. We've got this is bond work index here versus abrasion index. So this square here correlates to bond work index and abrasion index correlating together. They've got a 0.16 correlation coefficient, and we can see here in the same pair, but on the other side of the square, we've got diagonally. You can see that there really isn't a good correlation there, which is why it doesn't have a good value here. Whereas, for example, we've got a strong negative correlation between SG and A by B. We can see that here. It's very clear. It's a very strong negative correlation. Whereas SG and abrasion, we've got a pretty good positive 0.74 positive correlation between bond work index and SG. So we say SG and bond work index here, we can see that this one does indeed have a good positive correlation, and minus 0.69 for the corollary. Okay, so that's one way of doing it, if you already know what you want to look at, but quite often in geometallurgy we don't know what we want to look at. We might have, for example, bond work index, and we don't know what to correlate with, what other features in our data set might correlate to bond work index. So there's another button here, just drag one in here and you just hit O to correlate. Depending on the size of your data set, it can take a few seconds. This is a small data set, so it came up instantly, and you can see straight away that bond work index didn't really have much of a correlation with anything. But what it did do is say, okay, look, haven't got any good correlations there in the main data set, but I found some really good correlations for other things. For example, iron and sulfur have an excellent correlation, and pyrite, iron and sulfur have an excellent correlation, for example. And because I made this up from from mathematics. That's why it's such a good relationship there. And so obviously a red is positive correlation with a positive slope, and blue is a negative with a negative slope. That is our matrix plot. Now moving on to the XY plot, which is one of the most popular plots. It's a fan favorite. What can we look at here? We could look at, for example, we've already seen that bond work index and the SMC A by B have a certain negative correlation, but maybe wondering, maybe there's something else here. What else could we, how else could we divide this information up in order to see something more that might be going on? You can experiment, but for the sake of this tutorial, I'm just going to jump straight in and say, what about lithology? They got rock type lithologies. It might be something different there. So we can see that the volcanoclastics have got a higher bond work index and a lower A by B, so it's just harder and more competent rock. Whereas the sedimentary rock up here is the softer and weaker rock. And we've got a few other little things scattered in there. So that's basically how you populate it. You drag the features into these boxes here. You can delete them afterwards by clicking there, and then you just take them out, or you can just replace over the top with things. So for example, I wanted to put SG, I could put that, and then I could just drag bond work index over the top of that. I'll have it like that. What about if, for example, I was interested in knowing about how this would look versus copper grade at the same time? So I could just click the copper grade from a different table and drag it in here, and here we can see that the diameter is representing let me just click on the right here, the legend, and we can see show limits, and we can see that the large circles are 2.3 to 3.5% copper. So we didn't want to see the low grade, maybe it wasn't relevant for whatever reason, we can just click on it and it'll disappear. So we can click on different things and have them disappear like that. Or if you didn't want to look, for example, at the sedimentary rock, just click on it and it'll disappear. Okay, so again, you can move it around and have the scale you look at there, the size of the graph you like to look at. You can see also here when I move my cursor, you can see that it gives you the readouts there of where your cursor is and what the bond work index and SMC would be at each the point that the cursor's at. Something else you can do is click on an individual sample, and when you've got it selected, down here we call this picked properties. So you've picked a sample. This happens to be sample CBS 015, and then you've got a bunch of different features here that I'd previously selected. Let's just delete them, so just so we don't. So we just got sample ID and phase. So it's a sample from phase 2. Maybe I'm interested in knowing about the copper. Maybe I'm interested in knowing. So what have we got here again? We got A by B, BWY. So maybe I'm interested in knowing about the lithology, for example. Let's bring the lithology and the alteration up. They might be interesting things to look at. So you can see here I've selected a sedimentary sample, and sure enough, it's saying that it's sedimentary, but it's potassic alteration. So let's just choose another sample over here, and we can see that this is a volcanoclastic with a potassic alteration, and it's got a 3.5% copper grade, and that's why it's got a large circle. So they're all tied together. So this is a way that you could test outliers, for example. So you've got an outlying value that you wanted to know more about, you could find out where it is. Also, to help you find out more about the sample, you could click on this one here. This is the logs thing, and it'll take you to the logs. So you'll be able to see where the sample's from on your logs. Or you can click on this one here, which is the 3D icon, and it'll take you to the 3D view, and it'll highlight the sample 19 that we've selected, and it'll bring up this slider tool and look through the deposit on the 3 axes and bring the 3 axes just exactly to where that is, so you can get a good view of what's happening on the block model around about that one. It's got the label, and you can look relative to everything else as to where this interesting sample is. Maybe it's interesting because it's good, maybe it's interesting because it's bad, but this is a way you can do a bit more diagnostics as to what's going on with that sample. Okay, so that's the property picker. This is something that we've got in a few different kinds of graphs. You can also do shape, which I highly advise against. It's a little bit over the top. I mean, can anybody make sense of this? You can see, you know, circles and squares. That's kind of a last resort. What I do find it useful for, it's not, visually it's not very helpful, I don't think. But what you can do is, for example, if you only want to look at information from phase 2, it's kind of a little cheat. You can just do a shape by phase and then turn off one of the phases, and sure enough, you can do a graph of you know, phase 1 samples without having to go through the effort of you know, putting in a formal filter and filtering out all the data in the whole data set. So that's what sometimes, you know, shapes can be useful for. Okay, so there are some buttons here. You can send things. Well, okay. First of all, let's talk about how you can move the stuff around. Okay, so just by dragging, I'm just using my left button on my mouse, and I can drag things around. If I wanted to see things in a different way, I can use the scroll on my mouse, and you can see that if I put it in the thingy, the X and Y scroll to give it a different zoom. If I put the mouse over the X and use that scroll, I can just scroll just the X or just the Y, okay? And another thing I can push in, I'm holding down the scroll button, which is not a common thing that people do, but you scroll it in and bang, it'll just scroll in, it'll just zoom in to what was in that square. So let's just do that again. So say I wanted to look at this, you know, this, things are going what am I going to do? I've lost one. Okay, just click on this button here. Bang, it'll just take you back to where everything should be. Let's try that again. So I just want to look at this corner here. It's kind of interesting. So I'll just drag my square and release, and now I'm only going to see a zoom in of that. Okay, bang, using this button here takes us back to see everything again. Other buttons we've got, like say this one here is copy to clipboard. So it's going to copy this image to clipboard, and I just bring up, for example, my let's do it. Bring up an empty Word file, and I just go paste as an image here, and you see that it's given me the graph that I had, and it's also given me as part of the same image the legend. Okay, so as you can see, a lot of stuff going on here with a lot of things on the graph, so you've got a kind of complicated legend. But that's fine, you know, it's all good. We can, you know, if you've got a silly shape graph like this, and say, for example, you know, we didn't have these in there, so maybe this is what it looks like, and so you hit this again in here and go back to Word. We could just Control V to paste, and that's what you'll get. You know, so it's kind of a nice way to get images into your Word document if you're going to do a report. But basically what we do here is we just pick a reasonable size like that, and then we create all of our graphs using that same aspect ratio, and so the graphs are almost as, you know, squared away, all the same size, and of course, you know, the colors and the fonts and everything like that are consistent throughout. Right, so what else have we got here? What's going on? What about, for example, hide outliers? Now, it's not doing much here because we don't really have any outliers in the data set. But if, for example, you were to have, let's see if I can do something here that might be, let's go to, for example, the block one. No, that's not going to work. Let's bring up some, you know, residual copper versus, there we go. So we've got this kind of crazy thing going on here for residual copper versus acid soluble copper in the drilling. Okay, lots of points. What we saw in the previous few examples, we had data from metallurgical test work, so there's not too many data points, but you can see here when you've got, you know, potentially hundreds of thousands of data points, it's kind of hard to see what's really happening. So it can be good to have, for example, a heat map. Heat map basically is showing you the intensity of the data, and you can see that, you know, there's really not that many points. It looks like a lot of points here, really not that many points, not that many points here. Most of the data is in this bottom corner, and we can just zoom in on that, and that's what the data intensity looks like. That's one way to look at it. We can change the colors for the heat map if we want to waste time. Another thing we can do here is turn that off. We can go. I should go back to what we had before. What did we have before? It was bond work index versus, let's go. What do we have? Well, that's good enough. Versus SG, and I think what was it? Geology. I think we had lithology. That was a pretty reasonable looking graph. Okay, so my mind's eye tells me that we've got some volcanic clastics over here, and we've got some sedimentary here. I wonder whether my eye is having a lens. So I can go here, can show ellipses, and it'll show us what the 90th percentile probability is for the ellipses for where so the X is where the average of the data is for both the SG and the BWI, and then you got this ellipse that shows you where the distribution is. So it's basically like a two-dimensional box plot, if that's one way to look at it. But it gives it kind of a helpful tool to see where your data is centered. Okay, interesting. And we've also got a parity line. So, well, this is parity. You use this a lot for things like, well, let's, for example, say, what if we were to say, I don't really have, well, we can do this. What if I was to put, for example, head assays, right? So, well, here we've got the block model. So copper grade in the block model versus copper grade in the, in the drilling. Now I made this up, so this is all completely garbage data, right? But you can see how it might be interesting to look at how the copper grade in your block model correlates to the copper grade in your drilling, and the same thing could happen here for the lookups. We could, instead of looking at all that massive data, we could look at it just for the MET samples. This might be a better example. So just say, okay, copper in the block model and the MET samples versus copper in the geological drilling. Okay, well, this is pretty interesting. You can see that they're not very well correlated at all. If I, was to do my little jiggity jig and get them on the same scale, come on. Get together, Johnson. So I just zoom in on that one more time. So I just get that sort of like, you can see that the parity line goes to 1 to 1. We can see that there's not a very good correlation here at all between the drilling assays and the block model assays. So, that's useful to check that sort of stuff to see whether your geological assays tie in with your MET assays, for example. And you can change here what the slope could be. So maybe you might have some things that you might want to do 1,000 to 1, where you're going from, 10,000 to 1, where you're going from ppm to percent, for example. Or right now we get it plus and minus 10%. What if you want to, plus and minus, 50%. So that'll give you, depending on how precise you want the lines to be, 5%, so nice and tight like that, 10%. So it's up to you. It's just a sort of a helpful guide to see when you're trying to calibrate things. And in this case, for example, if we hit hide outliers, guaranteed stuff's going to disappear. So you can see that, the statistics say that a bunch of stuff up here are outliers. So hit the button, they will disappear from the graph. Can be useful. All right, so I think that we're pretty much there. The only thing I haven't mentioned is, you can reset the plot just by hitting the trash can at the top, or you can send the plot to the report, the reporting module, and just send it over there if you want. So that's XY plot covered. Now let's go to box plots. Hopefully you're already aware of what box plots are all about. Basically, it's a way of looking at graphically as to what the distribution of the data is in a simplified format. Just makes it easy for the eye to understand. Here we can see that we've got the blocks represents the quartiles. The dot represents the mean. The line is the median. Okay. And the bars are the standard deviations, plus and minus sigmas, right? So that's how the box plot's constructed, and kind of interesting, if you to put, for example, different things here, from a different scale. So you've got, abrasion index is usually around 0 to 1 more or less, whereas a bond work index is usually between 10 and 20 or something like that. So they're on a kind of different scale, kind of hard to see them side by side. So you go hit scale to log, and it just makes it a little bit more easier to understand how things might be relative. You're not really comparing them per se, but if, for example, we were to put lithology on there, then we can see how lithology affects bond work index and how it affects abrasion index separately. If we didn't have it on log, it just pushes all these together, and it just has. You can see pretty well the bond work index, but you can't really see what the abrasions are doing. So we'll just get rid of bond work index there, and we can see now. Okay, we've got. You can put your mouse over each box, and it'll give you the name of the box and the different statistics. And the interesting one at the bottom there, you see count equals 25. So there's 25 scores, 25 results in that box, 25 in this one, only 5 in this one, and 24 in this one. Kind of interesting. Now, you might think, where are the data points behind this? Well, the data points would have you think that all the data is just near the averages and stuff, but there can be outliers. So if you click on the show outliers, it'll show you them if there are any, because the fabricated this data doesn't look there is any. All right, let's find another. Let's put cyanide silver copper. Go to lithology, go and show outliers, and sure enough, we've got a whole bunch of, because the cyanide soluble copper's got a long tail. It's got a bunch of stuff that's got very high values. So they're not actually in the typical value range. That's why you get these outliers. So don't need that. Go on the logs, and you can see it's a bit more compressed. Anyway, let's get rid of that. Let's go back to our abrasion index. It was a pretty good one. And we'll go back to the geology, put on lithology. So, interesting that the breccia here seems to have a higher work index than the rest of the stuff. Breccia sometimes have high quartz. That might be the reason. Maybe there's a lot of quartz filling in the matrix. So maybe that's the reason. But statistics can be, these ones are a bit higher and a bit lower. If I was doing a geometallurgical model, would I want to have these as separate domains, or would I have them all grouped together? There's a lot of overlap. Well, we can do a Fisher grouping test. Just click on that, and Fisher will tell us that they're all the same color here. So all these other lithology types are really one group statistically. You can't really tell the difference between them, but this one here, the breccia has got statistically significantly different values to the rest of the groups, and so it should be treated as a separate group. So that's the box plots. What's next? Ternary plots. Fantastic. Anybody that works with copper, hopefully is using these all the time. Very interesting. You put cyanide soluble copper, your residual copper, and the acid soluble copper, and you can plot them in a three-dimensional, three-axis plot on 2 dimensions. So it's going from acid soluble copper from 0 to 1, cyanide soluble from 0 to 1 and residual copper from 0 to 1. So it's actually the ratio between them. They're not actually the values per se of the assays, it's the relative ratios. Now again, when you see this sort of thing like this, you think, well, it doesn't really, it just looks like a bunch of purple balls. Why would you get excited about that? Well, again, these are the hundred thousands of points here, so you really don't see what's going on. Let's turn on the heat map. Bang, we can see straight away what's going on. We've got a bunch of oxide and we've got a bunch of mixed sulfides. Okay, again, fabricated data, so I did come up with this, so it's not typical of what a copper project would look like, but as far as showing you how the graph works, I think it works quite well. So we can change the color scheme here, or we would have turn the heat map off, and what we can do is, for example, we could bring in here the copper grade as the color, and there we can see that all the low grade copper, once we turn that off, the stuff with low grade copper, maybe we actually see what's going on here for the stuff that's got interesting ore grade. And again, the same as XY, you can click on points, you can have the point pickers, you can have the going back and forth to the logs and the 3D. You can put on here size and shape and stuff like that as well. But it's basically the ternary plots. Very useful for if you've got good geochem, aluminum, potassium, sodium, magnesium, calcium. Those sort of elements can give you a really good idea about where your different lithologies are and things like that. And you can map accordingly. You can group them by lithology using Cancha, because you can correlate between tables. And so, for example, you could got a lot of stuff going on here. You can see here that the granites. Obviously down here you got a porphyry with granite, and it's got all the primary and the sulfide copper, and then other stuff, gravels, like gravels at the top where it's all oxide. So that makes sense. There's sedimentary all over the place. It's just manufactured data. Don't give me a hard time. So this next one here is a histogram of distribution plots. This is basically just it's kind of like what you've got down here in the left-hand corner for the different things. So, let's go back again to this assays, for example. We put copper acid soluble on here, cyanide soluble, sorry. You can see here that it gives you two things. It gives you a cumulative one here on the right, so this is a cumulative probability curve. And then on the left, you've got this frequency histogram, okay? So, you get 10 intervals, 10 steps for the histogram, and a continuous curve for the cumulative probability. And you can hit by ranges one, so this is just the ranges that are programmed into this cyanide soluble feature. So if you go to legend editor, you can change how many, let's just do that just for fun. Let's say, okay, let's go just to have 2 ranges, or let's go up to 7 ranges, and we'll do them all the same width. Let's do that. I don't know why we would do that, but we've done it. And so go back to analysis, and now if we hit here by ranges, you can see that we've got the 7 different ranges that we just programmed. And because we did it by the same width, which is a terrible way to do it, you can see that we've got an awful distribution, nothing in the higher ones. There's that. With this cyanide soluble copper, you can see you got a long tail up here, and it's kind of a lot of stuff grouped together in just this one bin. It doesn't give you a very good resolution, so just hit only less than 95%. So instead of getting to 100%, it only takes you 95% of the data and sort of squashes it a bit. This is a kind of a cheat that we've got for stretching out the interesting part of the graph. So you can see that you've got more detail as to where the distribution is on this end. Now, if we wanted to, we could, again, lithology, bang. So obviously, beware. You can make monstrous graphs if you want to. I don't know. It's not necessarily useful here. but what happens is it reduces from 10 intervals down to just 5, and you can see you've got all these different ones on top of you. Sure, you can turn a bunch off. That makes it easy to view, so that might be more interesting for you. But another way you could go is, let's give you a better kind of example. We'll go back to the bond work index, and we'll classify that by phase. And we can see there that what was going on there, how the bond work indices worked out by phase. Kind of interesting. That is that kind of histogram, the distribution ones. Next one, ratio chart. Okay. Ratio chart, it's kind of useful for a lot of data. If you've got a whole bunch of data, for example, let's go to the drilling, and you want to say, okay, we've got sequential copper throughout our drilling, and I want to know how the ratio of that is in a big data set. So we'll just start to list these on here. We'll put the copper acid soluble, the cyanide soluble, and the residual. I'll put them on there. And so what it does is, by the first value in this case was the acid soluble, it orders that entire drilling database from low to high, and here we can see we've got about 55,000 records. So it's gone from low to high. Percentage of acid soluble copper. So again, this isn't absolute assays, this is relative. So this is relative assays. This is the ratio, it's a ratio chart. So it's ratio of these three, the same as what we saw in the triangle or the ternary plots. So going from stuff that doesn't have any oxide at all up to the stuff that's the most oxidized, the highest acid soluble copper up here. And then the next one, we've got the yellow one, is the cyanide soluble copper. So you can see here that, throughout the life of mine, you're going to have a whole bunch of this. There's some stuff that doesn't have any residual much at all. Most of it's just cyanide soluble and acid soluble. And then you've got a bunch of stuff that really doesn't have much acid soluble. So I use this for things like, for example, copper to arsenic ratios, or lead to copper to zinc ratios. Maybe gold to silver ratios, or gold to copper ratios for leaching, these sort of things. Where you've got interesting ratios that might be able to give you an idea about what's happening in the deposit. And if you think there's a problem of high copper to gold, where you might have a high cyanide consumption, how much of the deposit's affected, and by drawing up this chart, you can see that. Right? Next one up is a distribution plot, S-curve. This is really good for looking at different results. So easy one, for example, would be to look at the bond work index, right? So we've got the bond work index, but we're wondering, are they higher results or lower results? Not sure. Well, we've got a database in here with a whole bunch of bond work indexes that was put together by Alex Doll and made public. So we've got this combination database in here, and you can just plot these bond work indices versus that database. And you can see here that the data that we've got is between sort of 10 and, what's that one there? Oh, can't click on it. So between 10 and 16 or something like that. I can click on this and see. So maximum value is about 16. And whereas the database goes up to, almost higher than 25. So we'd say this is a medium hardness. If we want, we could say, okay, well, how does it look by phase? And so we can get different colors by phase. These colors are kind of similar for phases, so let's just go to the legend and say, okay, let's just move these around a bit and give them a bit more contrast. And if we go back to analysis, we can see by turning things on and off, we can see where the phase 1 was and where the phase 2 was. So there you go. That's if we want to use the benchmarking. you can see the benchmark right now we've got AI and A by B and the crusher index and density and different values for comminution. But we turn that off and say for example we want to look at something else. Maybe we want to see how representative our samples were with respect to copper. So we could go to the block model and bring the copper from the block model into the line. And that's the distribution of copper in the block model. And now we're going to put the head assays for the met samples, and we'll put copper on that. And so now we can see the distribution of the copper assays in the samples that we've processed. And this is really good because you can see that we've got the whole line covered. We've got it right from the high grade down to the low grade. Not really many big gaps. It's all looking very nice and good. So this is a nice way to see whether you've got representative samples or not. Again, might be helpful to see how that looks by phase. So you can just turn those on and off again and see how they were by phase. Right, so that's the distribution plot. Next one, this is going to be quick because I don't understand much about statistics, but we can put abrasion index on there and we can see it by a normal distribution, or we can click on this and see it by wavable distribution. If you understand what that means, please write it in the comments below. But otherwise, you can click on stuff and you can see where the outliers are, and you can get different properties again. This is especially useful if, for example, you've got stuff that's been classified by lithology, for example, and you can see where there might be outliers because of things that have been misclassified on by lithologies that have been misclassified, things like that. Not 100%. We don't use this one a lot. Statisticians love it. There's a combination plot. This is really just to help you get your reports out faster and better. You might want to put, for example, what your SG and the SMCs are. Maybe you want to have, or better yet, for example, maybe SG by phase, for example. So it just puts a cumulative distribution curve alongside a box plot. So you can have the two together. So when you copy and paste that, you can just copy that and go to your Word document and paste it in there, and you've got a nice graph for your presentation. Put it in PowerPoint, whatever you want. Not terribly complicated. This next one's cool though. Check this out. So this is the statistics table. This is something that you do have to use a lot. You pull for example, your bond work index in, and maybe you've got a table here where it gives you all these basic statistics for your bond work index, right? You say, well, okay, that's interesting, but what do I want to know by phase? Okay, so group by phase. And so now you've got the statistics by phase, or probably even more interesting would be, let's do that by alteration. So now we can see potassic versus argillic alteration, how the maximum and the minimums and the number of values of bond work indices tests are. A whole list of different things you can have here. You can turn them on and off as you see fit. Once you've got your data sort of purged and well organized, or properly organized, you don't necessarily need how many text and null and negative values are and things like that, or even how many unique values are. But maybe you want to have certain percentiles. So when you turn them off, you can just readjust the size of your table using the orange corner here. And that's a table that you can copy and paste into your report or PowerPoint presentation, wherever it's going to go. You can also put more things. So say, for example, you wanted to have SMCs there as well. You could have the two next to each other, just like that. Perfect. Next one. This is a mosaic plot. Now, sometimes you've got categorical bins of data next to each other that you're not really sure what to do with. A classic example of that is lithology and alteration. In geometallurgy, we use these two a lot. And it's bin data, it's categorical. You've got potassium argillic for the alterations, and breccia and sedimentary and volcaniclastic and massive sulfide for lithology. So we've got these different bins of stuff. So it's hard to do statistics, but what we can do is, for example, if we wanted to, we could say, how is the, SMC A by B numbers? Well, A by B is not really additive, so let's go with bond work index. So we can see here that the volcaniclastics are the harder ones, and the sedimentaries are the softer ones. We saw that before. Maybe also we want to know what the number of samples that have been tested in each one were. So you just click on the count, and we can see how many were in each one. Well, okay, 19, is that a big number or a small number? Sometimes these tables can be quite large and complicated, so you can click on percentage of total, and now these are a percentage of the total. So you can see 24% of the samples were in potassic breccia, and only 3% were in potassic massive sulfide. This is good to know whether your distributions are matching, and because it gives these nice colors, you can sort of see side by side. If you were to have your geological data for drilling, for example, in the same format, then you'd be able to put them side by side and have a comparison. So there's, you count maximum, minimum, standard deviations and stuff like that. So really useful stuff. These don't, can't turn them on and off because of statistics, of course. Histograms. Histograms, again, frequency things, but a different way of looking at it. With a mosaic plot, you're basically looking at numbers and colors, whereas this one here, you're looking at the same thing, but you're looking at them, the frequency of things in there just by columns. So let's look at this, for example, bond work index tests. We've got 80 of them, or 79, whatever it is. 79 tests, and how are they breaking down by phase, for example? So we got them here. We've got 19 tests and 60 tests, in phases 1 and 2 respectively. What if, for example, we were interested in knowing that by what have we done? Sulfur grade, for example. So here we've got low, medium, and high grade sulfur bins. How many bond work index tests do we have in each one? So, here we could put, another one might be, for example, lithology. Could do that. So we've got a lot more samples in these and less in this, and that makes an awful lot of sense because, as we saw before, there's not that much of that rock type in the deposit. So yeah, these are categorical classifiers, and again, just as been saying for everything else, you can always copy here. You can send it to a report, and if you go to report, then your multigram it'll be all here, and you've got all the features that you've been using to construct this graph, and you've got the legend over here. Or you could just go ahead and click copy, and then go to Microsoft Word or any other kind of reporting or Office things, and just paste that in there, and then you've got your you've got this nice graphic for your report. Okay. So I think that's it for analysis. It was a big one because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 kinds of graphs. So it's a kind of a big one, but hopefully if you've had the patience to sit through some of this, then you'll have learned about how these graphs can work. Of course, at any time you can always hit the help button, and it'll take you to the user manual where there's similar kinds of explanations. That's the one way you can go through and analyze data in Cancha. Thanks for watching, and I hope you found this useful.